So we are going to talk about different formulas that are there when it comes to organic compounds, and especially now that we are talking about alkanes. Let's talk about different formulas, for alkanes. Different formulas for alkanes. In our previous session, we did talk about the first formula, which is the molecular formula. We are also going to look at structural formula. But before structural formula, we can talk about displayed formula. Number 3, we are going to look at condensed structural formula. And then just by passing, I'll touch on skeletal formula, though this one you're going to meet it a bit later. Let's look at skeletal formula. So let's begin by looking at the first member of the alkane, which is methane. Okay, maybe here is how I want us to do it. Let's have the name here. And we talk about molecular formula. Then we talk about displayed formula. Then we talk about condensed structural formula. Let's look at that. So number 1, we look at methane. From our previous lesson, we did say that alkanes have a general molecular formula of CnH2n+2. And we did also say that the prefix meth stands for 1 carbon atom. So this means C1, 1 times 2, 2 plus 2, 4. So that means our molecular formula will be CH4. Now, what about the displayed formula? In a displayed formula, we are going to open those covalent bonds surrounding the carbon atoms. So here we have 1 carbon atom. We said that the carbon atom must be surrounded by 4 bonds. 4 bonds in this case. Here we are going to have hydrogen, another hydrogen there, another hydrogen here, another one there. That is methane. Now, what is the condensed structural formula? Condensed structural formula is obtained from the displayed formula. Here is how we do it. You look at the carbon atom here. How many carbon atoms do you have? You look at the one carbon atom. Look at the number of hydrogen atoms surrounding the carbon. 1, 2, 3, 4. So H4. So this is to say, for methane, the molecular formula is similar or is the same to the condensed structural formula. We are done with the first member of the alkanes. Number 2, F, 2 carbon atoms, F, so ethane, general molecular formula. Okay, the general formula CnH2n plus 2. So here we have C2 because of the 2 carbon atoms. H, 2 times 2, 4, 4 plus 2, so that means H6. We're going to have C, H, no, rather, C2, H6. So, the displayed formula will look like this. You draw the 2 carbon atoms here. Between the 2 carbon atoms, we have a covalent bond there. Then add 3 more bonds surrounding the carbon here. So what you're saying is put a single bond between carbon and carbon. You realize that we have 3 bonds left for carbon to have 4. So put the 3 bonds here, put the 3 bonds on the other carbon atom. We are going to have hydrogen, hydrogen here, hydrogen, hydrogen there, hydrogen, hydrogen, hydrogen. This is the displayed formula for ethane. Now, we need a condensed structural formula from here. What we do is, look at the first carbon atom here. Write it down. How many hydrogen atoms are surrounding the first carbon atom? 3. So, this is going to be CH3. From there, move on to the next carbon atom. How many hydrogen atoms are surrounding the carbon atom? 3. Again, so write your C followed by 3 hydrogen atoms. So this is the condensed structural formula obtained from the displayed formula. That is for ethane. We swiftly move to the third member of the alkane homologous series. The third member is propane. Prop means 3 carbon atoms plus ane. The third member is propane. So for propane, we have, okay, let's come up with a formula from here, the molecular formula. N is 3, so C3H, 3 times 2, 6, 6 plus 2, 8. So we are going to have C6H8. So C3H8. There. Okay. The displayed formula for propane will look like this. Draw 3 carbon atoms. Put a bond between each carbon atom, a single bond. And then this carbon atom here has 1 bond already. So we need to add 3 more covalent bonds around it. So 1 here, another one there, another one there. Look at this carbon atom here. This carbon atom is surrounded by 2 covalent bonds. So add 2 more. So add one above, the other one below. From there, this other carbon atom has one covalent bond already. Add 3 so that we have a maximum of 4. So we're going to have 3 bonds there. And then let's put the hydrogens on the bonds created. H, 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 and H. This is the displayed formula for propane. Now, how do we write the condensed structural formula from the displayed formula? The drill is the same here. Look at the first carbon atom. This first carbon atom has got 3 bonds with it. 3 bonds with it. So this is CH3. The second carbon atom, C, has 2 hydrogen atoms. Okay, with it. So this is going to be CH2. The third carbon atom, C, is surrounded by 3 hydrogen atoms. And that is the condensed structural formula for propane. So, let's go to butane swiftly. Butane. All right. Formula, let's find out. Butane, 4 carbon atoms. C4H. 4 times 2, 8. Remember this general molecular formula. 8 plus 2, 10. So we're going to have C4H10. All right. Draw the carbon atoms, 4 of them. Join them. Between them, let's have a covalent bond. So we're going to have 1, 2, 3, 4. All right. Let each carbon atom be surrounded by 4 bonds, as you've already seen there. Then let's put our hydrogens on the bonds created. H, H. There. From there, let's get our condensed structural formula from here. We're going to have C, the first carbon, surrounded by 3 hydrogens. First carbon surrounded by 1, 2, 3. The second carbon surrounded by 2, CH2. The third carbon surrounded by 2 hydrogens as well, so CH2. The third one surrounded by, the fourth one rather, surrounded by 3 hydrogen atoms. Now, you can leave your answer like this. You can leave it like that, or you can write it this way. Have your CH3 here, and then there are 2 CH2s in the middle. So use a bracket. Have your CH2 here. How many are they? 2. Then write the CH3 at the end. So the CH3 at the beginning and CH3 at the end must remain. Now the CH2s in the middle, you can put them together this way. If there are 2 of them, brackets 2. 3 of them, bracket 3. And so on and so forth. So it can be this or that, both of which are allowed. So that is butane for you. So with that, we can continue with pentane, hexane, all the way to decane. Same technique. So at this juncture, I wish to stop at this point and encourage you to use the same approach to continue with the table to fill this table up to carbon number 10. All right. Alkanes. When it comes to naming alkanes and other homologous series, as you're going to see, there are rules involved, rules to be used, rules to guide us when it comes to naming of alkanes. Let's write the following. Here, when naming alkanes, the following rules must be followed. The following rules must be followed. Rule number 1. Identify the longest continuous carbon chain. This is the first rule. We need to identify the longest continuous carbon chain. But there's something I have to say here, that the longest continuous carbon chain does not necessarily have to be straight. It can be crooked so long as it's continuous. So that point is very important here, that the longest continuous carbon chain does not necessarily have to be straight. It can be crooked, and it's all right. It can be crooked. Crooked or what? Bent. It can be crooked or bent, and it's okay. We can have your longest continuous carbon chain straight, as indicated, or you can have it this way. Your longest continuous carbon chain can look like this. It doesn't have to be straight. It can be crooked like this. It doesn't have to be straight so long as it's continuous. So it's your work to identify the longest continuous carbon chain. So long as it's continuous, it's okay. It doesn't have to be straight. It can be crooked, as you can see. All right. Rule number 2. Identify any branch. Now, this branch sometimes is referred to as side chain. Identify any branch or side chain attached to the longest continuous carbon chain. You identify. Now, this branch at this level, this branch can either be an alkyl group or it can be a halogen group. So that is also important to note that the side chain can be an alkyl group or a halogen group. Okay, let's look at the alkyl group branch. Alkyl group branch. The alkyl, the name of the alkyl group, the name of the alkyl group is obtained by removing the A and E from the name of the alkane and replacing it with the suffix YL. That for you to be able to name the side chain that is an alkyl group, what you need to do, first of all, you need to identify the parent alkane from where we are going to obtain our alkyl group from. Remove the suffix ANE from the name, then replace it with YL as follows. If I have methane, okay, so let's talk about parent alkane alkyl group. Here, let's talk about methane. So from methane, remove the A and E. The side chain is going to have a name, meth. Now replace the A and E with the YL. So we're going to have methyl. From ethane, remove the A and E. The side chain is going to be, the name of the side chain will be ethyl. You remove the A and E, you replace it with YL, ethyl. If it's a 3-carbon member, propane, remove the A and E, replace it with YL, we are going to have propyl. And so on and so forth as such. If it's butane, butyl, pentane, pentyl, like that. Now, there's one other thing we need to talk about. The alkyl group is usually one hydrogen atom less. One hydrogen atom less from the main or the parent alkane. That's how do you recognize your alkyl groups? You look at the number of carbon atoms. For example, methane, we know, has a general formula, molecular formula, rather, CH4. So, remove one hydrogen here. You're going to have the alkyl group methyl is going to look like CH3. So, when you see a CH3, how many carbon atoms? 1. It came from methane. So, remove the ANE, replace it with YL. We are going to have methyl. So remove one hydrogen, whatever you get, it's a methyl. All right, give me ethane. Ethane has a formula, C2H, C2H6. Remove one hydrogen, you're going to have C2H5. Remember, this one can also be given as this, CH3, CH3. If this is the case, remove one hydrogen, CH3, CH2. So that is ether. For propane has the formula C3H8 or CH3, CH2, CH3. Yes? So remove one hydrogen from the last one. You're going to have, okay, if you remove one hydrogen here, it's going to look like C3H7. Remove one hydrogen here, we're going to have CH3, CH2, CH2. You just count the number of carbon atoms. So that's a propyl. Remember, the alkyl group is usually one hydrogen atom less the parent alkane. Very, very, very important. Remember, we have two types of side chains. We have the alkyl group. We can also have the halogen group. So, let's talk about the halogen group as a side chain. So, halogen group. Halogen group. We know that halogens are group 7 elements. Just to remind ourselves, group 7 is one of the most unique groups we have in the periodic table. Reason, the halogen group or group 7 has members from each state, physical state, has a member from each physical state. What do I mean? Fluorine, F2, chlorine, Cl2. These two are gases. Go to bromine. Bromine, Br2. This one is a liquid at room temperature. Go to iodine. I2. Astatine. At2. These two are solids at room temperature. So group 7 is a very unique group because it has a member, at least one member from each physical state of matter. We know that fluorine is pale, just so that we can do a recap on that. Pale yellow. Chlorine, pale green. Bromine, brown. I should, at this juncture, I should emphasize that there's a difference between bromine liquid and bromine water. Bromine liquid Br2 is brown in color. Bromine water, however, HOBr, that is bromine water, is yellow. Or rather, let's go with orange. Bromine water is orange. Let's go with orange. Bromine liquid, brown. Bromine water, orange. So you need to know what they're talking about in any particular question so that you're able to differentiate. All right. Iodine is gray, shiny gray, solid. Astatine is a black, solid. So it's important for us to know that. Now, why is this important? When the branch is a halogen atom, when the branch is a halogen atom, come on, what do? We replace the suffix INE on the name with O to get the name of the side chain. Name of the side chain. All right, so let's look at this halogen. Name of side chain. Okay, so if you have fluorine, remember it's fluorine, not fluor. Most students make a mistake here. Fluorine. So we remove the INE, we have fluor. Then we add O. So fluoro. So the side chain will have a name, fluoro. Very important here. You have chlorine. Remove the INE, add O. You're going to have chloro. Okay. So bromine. Remove the INE, add O. You're going to have bromo. And so on and so forth. So if you have iodine, for example, you remove the INE, you add O, we are going to have iodo. Astatine, esteto. So that is how we name the side chain. So these are two common side chains, but mostly in an examination, expect questions on the alkyl groups, but it's important you also get to know about this. So that is rule number 2. Let's go to rule number 3. What is the third rule? Rule number 3. Rule number 3. Rule number one, remember, we have identified our longest continuous carbon chain. It doesn't have to be straight, it can be crooked so long as it's continuous. Two, we have identified any branch, any side chain from the longest continuous carbon chain. Rule number three, number the longest continuous carbon chain and name it as a parent alkane. You identify the longest continuous carbon chain, then name it as the parent, depending on the number of carbon atoms available. When numbering, do so from the sides. We do so from the side that will give us the smallest possible number on the locant carbon atom. When numbering, do so from the side that will give the smallest possible number, to the locant carbon atom. The locant carbon atom. Now, what's a locant carbon atom? A locant carbon atom, it's important for us to note, locant carbon atom is the carbon atom where a branch is attached. That's very important, where a branch is attached. Now, in case, this is very important now, in case of multiple branches, what do? We should number our longest continuous. We should number our longest continuous carbon chain, so that the sum is now very important. So that the sum of the locant carbon atoms, the sum of the number, let's put it that way, the sum of the number, so that the sum of the number of number on the locant carbon atom is smallest possible. That is rule number 3. Rule number 4. Very, very important to follow these rules. Rule number 4. Arrange the name starting with the side chains. Side chains which must be in alphabetical order. Which must be in alphabetical order. We are going to put heads and tails to these rules when we do an example shortly. Rule number 5. Very important. Rule number 5. Separate numbers. Separate numbers using commas. You separate numbers using commas and separate numbers from names. Using hyphens. So to separate numbers, let's say you have 2, 3. Between 2 and 3, you must use a comma to separate the numbers. But between the numbers and the name, let's say butane, for example, 2, 3, whatever it is, butyl and all that, separate the numbers from names using hyphens. Very important. That is number 5. Rule number 5. Let's go to rule number 6. There are 7 rules I'm going to give you. So rule number 6. These rules will help you when naming organic compounds, be it alkanes, alkenes. These are the rules to follow. Rule number 6. Use the following prefixes when we have multiple number of branches of the same type. So, for example, when you have 2 branches of the same type, we use the prefix di, di. This is for 2 branches of the same type, yeah? Use the prefix tri when you have branches 3 branches of the same type. So 3 branches. And finally, rule number 7. Use small letters when naming organic compounds. In this case, alkanes. Remember, there should be no space. There should be no space. There should be no space or spacing. There should be no spacing in the name. Those are the 7 major rules for naming alkanes or organic compounds. Now, I want us to look at examples so that we can use these rules. I want us to look at an example. We name an organic compound, an alkane, using the rules we have just stated. All right, so let's look at examples here. Let me start with the first one. I've been told, name the following alkanes. Name the following alkanes. The first one, part A. First one, part A. Let me write it up here. A. We have this.
Now, the last meeting, I would like to speak about is just how to state alkane graph. There's so much involved about it.
Remember, when you're drawing your organic molecule, the bonds must not touch the atoms. Remember, these atoms must not be touched by the bonds at any given point.
Now, the first thing I want to understand about alkane graph is that it has no amplitude. So basically means that you cannot limit alkane graph. For example,
There. So, I want us to name that molecule. Rule number 1 tells us that we need to identify the longest continuous carbon chain. Looking at this, I can look at it this way: 1, 2, 3, 4, 5. This can be my longest continuous carbon chain. Or I can start from here: 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. So whichever way you look at it, the highest number of carbon atoms on that chain is 5. So 5 carbon atoms. Let me take this as my longest continuous carbon chain. This straight one. How many carbon atoms? 1, 2, 3, 4, 5. So what alkane has 5 carbon atoms? We know from our previous session that an alkane with 5 carbon atoms is pentane. So you write that parent name somewhere. So the parent name for this molecule is pentane. We have identified the longest continuous carbon chain. Then from the longest continuous carbon chain, do we have a branch? Yes. There is a branch here, as you can see. Look at this branch. This branch has got C with how many hydrogens? 3. CH3. CH3 is an alkyl branch, an alkyl group. And that alkyl group, we call it methyl. So we have a methyl, CH3. We have a methyl. So we have identified our branch And we have identified where that branch, the name of that branch rather. Number 2, we need to number our longest continuous carbon chain now. Let's check. There are 2 sides. Assuming we number from the left-hand side, we are going to have 1, 2, 3, 4, 5. So it means the locant carbon, the carbon atom with the branch, is labeled number 2. Now, assuming we want to number from the left-hand side, let's see. 1, 2, 3, 4, 5. If you decide to number from the right-hand side, the branch will be at carbon number 4. So in this case, we choose the numbering that will give us the lowest number on the locant carbon. In this case, carbon number 2. So that means at carbon number 2, we have a branch called methyl. Do we have another branch? No. So let's put the names, those names now together to form the name of the compound. We are going to have, start by writing the position of the branch. 2, 2, what do we have on 2? Methyl. Remember we said one of the rules was you separate the numbers from the names using a hyphen. So 2 hyphen. At carbon number 2, we have a methyl. How many methyls do we have? Just 1. So just say 2 methyl. Remember small letters, methyl. Do we have another branch? No. So after that, put the parent name. Once you have already named your branches, put the parent name here. Remember, leave no space. So 2-methyl pentane. Remember small letters. 2-methyl pentane. And that is how you name the alkanes. This is the name for that molecule. Let's look at another one. Let's look at another one. Another alkane. Another alkane. Let's see. Let's look at this one, B. Let's look at carbon, that hydrocarbon, that alkane. So first things first, locate the longest continuous carbon chain. Let's find out. You have options. Let's look at our options here. 1, 2, 3, 4. I can look at it linearly. 1, 2, 3, 4. Or I can say 1, 2, 3. So 3 is less than 4, so we discard that one. 1, 2, 3. That is also out. Or you can start from here. 1, 2, 3, 4. Or 1, 2, 3, 4. Or 1, 2, 3, 4. So whichever way I look at it, the biggest number of carbon atoms is 4. So it means I can choose to go with a straight chain. This is my parent. This is my parent alkane, which has 1, 2, 3, 4. 4 carbon atoms. Now, what is the name of the alkane with 4 carbon atoms? From our previous session, we know that that is butane. So the parent name is butane. Let's put our parent name there. We already have our parent name. Number 2, from the longest continuous carbon chain, do we have branches? That's the next question you ask yourself. Yes, we do. We have the first branch here. we have another branch there. So, by look of things, those branches are identical. This is a methyl. This is also a methyl. So, our branch is methyl, but we have two of them. Remember, we have two of them. We are going to talk about that. Next, let's number our longest continuous carbon chain. Where are we going to number it from? Let's try. Let's number it from the left and see what happens. 1, 2, 3, 4. If we number it from the left-hand side, the branches will be at carbon 2. But if we number the longest continuous chain from the right-hand side, let's find out. 1, 2, 3. The branches will be at carbon number 2. So we can, number 3. So we cannot number from the right, because the right will give us the biggest number on the locant carbon. So we number from this side. 1, 2. So at carbon number 2, we have a methyl. At carbon number 2 again, we have another methyl. So here is how you're going to do it. You're going to say 2, 2. You must state the numbers to which the branches have been attached. So at carbon number 2, we have a branch. At carbon number 2 again, we have another branch. Put a hyphen. So between numbers, separate using comma. Between numbers, we put a comma. We separate numbers using commas. Okay. Between numbers and names, we use hyphens. So 2, 2, hyphen. What is the side chain? Methyl. How many are they? There are 2. So we said when we have a multiple number of identical side chains, we use the prefixes di, tri, tetra, penta if you have to. So in this case, we have 2 of them. So we use the prefix di, methyl. It means methyl. It means at carbon number 2 and number 2 again, we have 2 methyls. So 2, 2 hyphen dimethyl. Do we have another branch? No. Bring the parent name and put it here. Leave no space. Remember to use small letters all through when naming organic compounds. So the name of this molecule is 2, 2 hyphen dimethyl butane. That is how we name molecule number 2. That is in B. All right. Let's name another one. Let's name another molecule. Let's name another molecule. Okay, let's make things interesting now. Let's have this one. C. All right. So we want to name that organic molecule. Let's find out. How many carbon atoms do we have? And what is the longest continuous carbon chain? 1, 2, 3, 4. All right. 1, 2, 3, 4. Okay. 1, 2. Okay. 1, 2, 3. 1, 2, 3, 4. Okay. 1, 2, 3. All right. So you check. After checking, we have seen that the maximum number of carbon atoms we can have on a continuous carbon chain in this compound is 4. The parent name butane. So write it somewhere. That is the first thing you do. Second thing, do we have, wait, we have said that our longest continuous carbon chain is this one now. You can isolate this way. Okay, now look at the longest continuous carbon chain. Do we have any branches coming from it? Yes, we do. There's a branch here. I don't know what that branch is. We are going to recall what we just looked at. We have another branch here. We have another branch there, another branch there. There are 4 branches. So F comes from fluorine. So there's a fluoro. Write them somewhere down. There's a fluoro. There is a methyl. There is a chloro. And then there's another chloro. So how many different types of side chains do we have? 3. Methyl, fluoro, and chloro. Let's talk. From there, we need to number our longest continuous carbon chain. Let's number. Let's see. 1. If you number from the left-hand side, we are going to have 1, 2, 3, 4. If you number from here, 1, 2, 3, 4. So whichever way we number, the branches will be at carbon number 2 and 3. 2 and 3. So in that case, we can go with either. Let me number from the left-hand side to the right. 1, 2, 3. Good. At carbon number 2, we have a fluoro. Carbon number 2 again, we have a chloro. Carbon number 3, we have a methyl. Carbon number 3 again, we have a chloro. So that one we understand each other. We are okay up to that point. But here is a question. How should I arrange my side chain? Which one should I begin with? And that is why we are going to go back to our rules of naming. We said the names of the side chains must be arranged alphabetically. All right, let's look at F, M, and C. So in this case, the first side chain we are going to write down is chloro, because C comes before F and M. So let's look at where C is. At carbon number 2, there's a C, a Cl, chlorine. At carbon number 3, there's another chlorine. So you're going to say 2, 3 hyphen. How many chloros do we have? How many chlorines do we have? 2. So you say dichloro. So we are done with chlorine. 2, 3 hyphen dichloro. You have chlorine. Okay. From C, what is the next letter on the alphabet? Is it F or M? F. F is next. So we need to name the fluoro. Fluoro is at carbon number 2. We said between the name and the number, we must put a hyphen. So hyphen 2. Because we want to number, we want to name the fluoro. 2 hyphen. How many fluoros do we have? 1. So 2 hyphen 2. No, 2, 3 hyphen dichloro hyphen 2 hyphen fluoro. So I'm done with fluoro. The last one is a methyl. Methyl is at carbon number 3. So between the name and the number 3, you put a hyphen 3. Between the number and the name methyl, again, you put a hyphen. Methyl. And then once we are done arranging our side chains, we put the parent name at the end, no spacing in between. Butane. That is how we name molecule number 3. That is part C. So I want to give you D. Try naming the 4th molecule We will continue from there in our next session. So the molecule is here. C, 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 C. There's a C there, another one there. Let's have another C here.
And then you're told you have to calculate energy transferred to the communication state on those hours. If you're dealing with accumulating energy, power and time is that, first of all, you must understand that power is the rate of energy transfer. So basically means that power is energy transferred per second. Energy transferred per second. That's why the SI unit of power is watts, but also we can use joules per second. Okay. So in this case, our energy becomes 2.27 watts. Put over time for 12 hours. But we need to convert this hours.
So try naming this molecule. I will see you in our next lesson. Thank you.